Okay, guys, welcome back to my Smarter YouTube playlist. So today I will show you how to first calculate rainy days and then map it by using R. And then we also will do a trend analysis by using R by using a Mann-Kendall test. So let me share my screen first. I will share the entire screen. Let's go directly to the point. So this is what we are going to do. We want to map something like this. So we want to calculate annual rainy days for Peninsular Malaysia. So the data we will use a CHIPS rainfall dataset. So as you can see here, the mapping show where is the higher rainy days in Peninsular Malaysia. Rainy days mean rainfall that is higher than 1 millimeter. If rainfall higher than 1 millimeter per day, then it is considered as rainy days. So as you can see in Peninsular Malaysia, in the west coast of Peninsular Malaysia, there is higher rainy days compared to the east coast of Peninsular Malaysia. This is quite surprising actually, because the east coast is usually have a higher extreme rainfall, even though that is higher extreme rainfall, but it actually have lower rainy days. But when it rainfall in the east coast of Peninsular Malaysia, when it do happen rainfall, especially during the monsoon season, northeast monsoon season, then the amount of rainfall is very high. So, but this is the index for this is the rainy days. We calculated the rainy days usually is higher in the west coast of Peninsular Malaysia. Even though rainy day is higher, it doesn't mean that the amount of rainfall is high. Sometimes the amount of rainfall is quite low, so flood doesn't happen. Like in this case, in west coast of Peninsular Malaysia, there rarely happen flood here, but the amount of rainy days is higher compared to the east coast. So we want to prepare something like this, and the plus sign in the map means the significant change. So positive mean increasing trend, negative mean negative trend. But all of the annual rainy days based of Mann-Kendall test show that there is an increasing trend in the Peninsular Malaysia, especially in the upper half of Peninsular Malaysia and the west coast of Peninsular Malaysia. That means this area will receive more days with rainfall. You see the higher rainfall is more up to close to 300 actually. So there is up more than 260. That is more than 70% of the days in Peninsular Malaysia is actually rainy days, very high rainfall occurrence. So let me show you the how I do this one. So in this case, first I will calculate annual rainy days for each grid point for Peninsular Malaysia. So first we use a library D player, install it. If you still don't install it, install this D player working library, and then you set your working directory. So our working directory where I put all my CSV file is in this folder. So let's see this folder. So we go to research, circling just now, analysis. So the data, this is the working directory, D in this folder. So I put all the data here. So I'm using a chips. So I read this SV file, which is a chips rainfall dataset at 0.25 resolution. So let's read this dataset. So chip PM, say this one. So let's open this dataset. So this dataset, I'm arranging it with year, month, and day. So we have 1981 to 2023. So this is daily data. So we have here column 4 until column 181 is actually until 178 is a grid point. So covering all the grid point in Peninsular Malaysia. So this is all grid point based on the CHIPS rainfall data. So this is daily rainfall for covering the whole Peninsular Malaysia. So we read that dataset just now, and then we create a date column by combining year, month, and day column here. So if we view our data now, we can see that I use a view function to see. So it will have this new date here at the end of the column. Where we create a date column, which we combine year, month, and day that I used just now into this kind of format from 1981 to 2023. And then step 5 is we define the grid point column from V1 to V178. So we only read the column with V from 1 to V1 to 178. And then we calculate annual rainy days for each grid point. So we group it by years. And then we summarize the data calculating mean rainy days for each grid point, which is a mean annual actually. So we summarize, we call this mean rainy days. So we sum it up. So any rainfall that is higher than 1 millimeter, we will consider it as rainy days. So we calculate this one. So calculating is very easy. And then we can print the result. So we print the result by using this code. By just print normally, and then you will get this chips Peninsular Malaysia grid rainy days mean annual rainfall. So I put another naming system just so that it will not overwrite my previous data. So I have write the result into CSV file. So we have what's the name chips this one. Okay, so this is the result for rainy days. You see, we have V1 until V178. So from 1981 to 2023. So this is the number of rainy days in Peninsular Malaysia for each grid point, chips grid point. So the result looks quite good. You see, rainfall is quite high. Rainy days is quite high in Peninsular Malaysia. We have a lot of rainfall. So now we use Mann-Kendall test just to see this result just now. We will do a trend analysis for each of these grid points to determine which grid point have a significant change, is it positive or negative. So we use this, this is the code. We use modify MK library. So use this modify MK library and then set our working directory, and then we read our CSV file just now that we prepare for rainy days. And then we want to analyze from column 2 to 178 because the first column just now is years. So we read the second column until 179. So column to analyze is 2 to 179. And then we create empty data frame to store the result. So we calculate, this is the result for, this is empty data frame we as vars, p-value, and tau. So this we create first, and then we perform Mann-Kendall test. So this is the Mann-Kendall test. You use this code to calculate Mann-Kendall test. You see here MK test for that call, and then result for each of these the result for column z values and slope as vars, p-value, and tau. We kind of extract all of this result, and then we can run this one. See, it's very fast. And then we write the result for Mann-Kendall test for rainy days. So here we write the result. So we will have this result, Mann-Kendall result for rainy days. So we have all of this value, right? But this is just the result for value of all the each grid point that we use from grid number 1 until 178 just now. this is all the statistic related to Mann-Kendall trend test. But we want what we want is is it significantly increasing or significantly decreasing based on a certain confidence level. So we calculate again with the result that we have just now. We read that result, and then we signify give a significant level of 0.05, 95% confidence level, and then we want to identify significant trend, and we want to label them directly. So we based on that result just now, we get the trend label, and then identify significant trend and label them. So if the result is less, this is the result for trend label, result p-value, we take p-value alpha and slope all just now, then it will become positive. If significantly negative, then it will label as significantly negative. If there is no significant trend, there is empty. We will put it empty. So now we win the result. This one. So we get trend based on Mann-Kendall test with labels for rainy days. So now we have this trend result. Okay, now you see the result for trend analysis, trend statistic for Mann-Kendall is there, and then we also have the trend label. So some grid points show a lot of positive here, but some grid point also empty. There is no significant change. Some of the grid doesn't show any trend, but most of it show positive trend, right? So it will see that there is a significant increasing trend for most of the grid point in Peninsular Malaysia based on Mann-Kendall test at 95% significant level. So now we want to map this result. So we map it by using this code. So we use ArcGDAL library, raster, SP, and R-Color Brewer. You can install it. And then we use the same working directory just now, and now we want to plot so we want to plot it. We create another file where I put the plotting which have the length and long of that grid point just now, and then we have rainy days. So for each grid point, so rainy days you will get it by the first you have the result for rainy days just now, right? Let's see. Mean annual, this one. So for each grid point, you just take the mean value. So you just take the mean value here to get the value for each grid point. Yeah, you can just take all of the mean value here, and then put it here for transpose. Okay, you will get this rainy days mean value from 1981 to 2023 for rainy days for each grid point. And then the trend rainy days here, you get it from this trend analysis just now. You can just copy this trend and put into this file, and then you will get which grid point has the positive or negative significant change. So you actually need late, long, rainy days, and trend rainy days. But this is all other result that I get, but we focus on rainy days. So we have prepared this file. So actually our code will only read the column name. So make sure you remember the column name here. This is for rainy days, the value, and then trend rainy days for significant change. And we also have late, long. So now we read the data set just now, and then we should read our shape file. So we have our shape file. We put it in the shape file, here. Peninsular Malaysia. So if you have ArcGIS, you can prepare your study area shape file. So you put it here. What we will read is PM shape file here. This file. So with our working directory where we put our shape file, which is PM, and then we reproject that shape file to WGS84 just to confirm the projection is homogeneous. And then now we read our raster file where we have let long and rainy days just now. So this will read our result for rainy days, annual mean rainy days. And then we set the color palette for the map. We use blue, gradient blue from light blue, blue to dark blue. And then we define legend labels as days. So the legend label is days. And then we create the map for annual rainfall. So annual uh, mean rainy days actually. Rainy days. So def new, right? This is the size of the plot. And then we plot our raster, rainfall raster just now, which is this rainy days. Rainy days means our data set here that has rainy days. Create this column for rainy days. And then the main text title of the map will be annual rainy days, annual mean rainy days. So from 1981 to 2023. So other than that, we have font, what family A, and then check exists 1.5, and then we plot by using this Johor. Actually, this is Peninsular Malaysia for our basin just now. Actually, it's just the name I use is Johor Basin. So we can plot this one. See, it's plot the rainy days. Annual mean rainy days from 1981 to 2023. So the legend is days. So the west coast have higher rainfall, and the east coast have lower rainy days. Not rainfall, rainy days. And then now we have the plot of spatial mapping, but we want to have the significant change of the map into the map. So we use this code adjust. So this is the code for let long, annual rain, let long, labels and when. So we run the train ready this just now. And the most important part here is this value. So this will adjust your position of the plus significant change into left, right, so that it position on the grid point. So sometimes it's going at different place. So you must reposition it until it show on the map. So the color of this significant change is I put it black. Say and then one. Okay, now it's plot on the map where is significant change is happening. So what is mean here is that some of the west coast area that is already have higher rainy days will have even more higher rainy days in the future. The trend is like that. And the east coast, even though there is lower rainfall, lower rainy days historically, but there is also a trend of higher rainy days in the future. So that is what it means by trend analysis. Sometimes people confuse spatial mapping and trend mapping. Trend show the trend in the how it changed historically. Spatial mapping show how it rainfall is rainy days is higher, especially historically. So trend tell you is that area will become more rainy days or not? That is the question. So like in the west coast, there is more rainy days. In the east coast also there is will be more rainy days at the upper half of Peninsular Malaysia. This this is too big concern that in the west coast, some flooding area will will face more higher rainy days, but it need to be confirmed if the rainy days have higher rainfall or not. And the East Coast, we know that is face a lot of heavy rainfall, extreme rainfall. So more rainy days, does it translate with higher extreme rainfall or not? That is need to be confirmed later on. But we know that rainy days is increasing over the years. Okay, I think that's all for this session. I hope this will be helpful.